Okay.
All right. So welcome to the conversation that we do have today in operations research. And I want us to consider assignment problems. Assignment, assignment problems. Now, here is the concept of assignment problems, the basic concept thereof. It says that this is where actually it's basically an extension of transportation problems. So what usually happens here is that each source, should at least have capacity, on its own to satisfy the destinations. It's different from the transportation problems that you had. Because here we want to make sure that since there are different sources and different source destination, but each of the source should be able to, satisfy the destinations, all the destinations given. And this is the concept of assignment problem. Now, assignment problems can be defined, can be broken down into the balanced assignment problem and the unbalanced. We are good. We have balanced
Yes.
ones and the unbalanced. With the balanced ones, the columns are equal to the rows. Is that clear? The columns are equal to the rows. Those are balanced ones. The unbalanced ones, the columns are not equal to the rows. Columns are not equal to the rows. And then those are said to be the unbalanced problems. You're good?
Yes,
Now,
sir.
what I want to introduce you to is the use of Hungarian method. Yeah, not not Hungarian sausage, Hungarian
But
method.
sausage plenty in my boss.
Eh?
So from my sausage plenty in my boss.
uh, Hungarian method to sort out the problem. Now, listen. What we are trying to assess here is how much time can it take for us, to move, say, the products from this source to this particular destination? What is the optimal time can it take? Or if it is in terms of production, how many hours, how many minutes can it take to produce this particular product? And what's the optimal, number of minutes? Um, what is the optimal time really? So um, optimal versus assignment problems, therefore, will have the following focuses. The following are the focuses. Number one, it focuses on helping you. The first step is just to make sure that you have the initial basic problem. Just like in the transportation problems. You have the initial basic solution. And once you have the initial basic solution, number two is to test the optimality. Test the optimality. Test how optimal that solution is. And once you test the optimality of the solution, then you should be fine. If it shows that it is optimal, then you should be good. Is that clear?
Yes.
So what we are going to do now, first of all, I'm going to give you a table that you're going to work with in this very conversation. So I was emphasizing that assignment problems can be divided into balanced and unbalanced. Yeah. So if you do have the unbalanced one, if you happen to have the unbalanced problem, it becomes very incumbent that you balance it. Balancing the unbalanced assignment Sorry, the it. Okay. Are we still connected?
Yes, boss.
Hello?
Hello? Hello?
Mm. So, yes, we can now go ahead. Yes, can you hear me?
Yes, I can.
You have operators, and these are the entries that you have in terms of time. There is 9, 11,
I can't see the screen, boss.
14. You can see the screen. It is being
Yes.
shared.
It's being shared. Maybe it's the network because here it's just showing the log for the institution.
Mm. I am actually sharing it.
That's when it has started now. So stopped maybe after the network check.
Okay. Okay. So from there you have 6, 15. Are you able to write this somewhere as well? Are you writing even? You have to write down
Yes,
these steps you need.
yes.
Okay. And then from there you have 12, 13, 6, 8, and 8. From there you have 11. From 11 you have 9, you have 10. Then you do have 12, and you have 9. And from there you also have 7. You do have 7. You have 12. From 12 you have 14. And from 14 you have 10 and 14. You've seen these numbers?
Yes.
So this one is said to be a balanced what? A balanced problem because the number of columns uh, is equal to the number of what? Of number of rows. If it is not balanced, for example, you have fewer columns than the rows, then you can add a dummy row or a dummy columns. If the columns are few, I mean, say here they are 66 rows, for example. You're seeing, right? So like
Mm-hmm.
the rows are 6. It's just a dummy column as zeros, like zeros. That's a dummy column. So it would have now made six columns. You get the point, right? And vice versa. That's how you balance, first of all.
How do you know if they are
Okay?
balanced? Like, so you just count the number of rows and the
You
number of
can just
columns?
count the rows. Count the count.
Oh, okay.
Mm.
Network today is bad. So,
Now, the network is cutting.
yes.
Hello?
Hello?
Okay, is there any improvement now? Hello? Is there any improvement?
At least now. At least.
Okay. These are the steps that you have to follow, and you should write them down. Number one. One is for Are we bad? Network is really bad. Let me try to network, yeah?
Tá?
Yeah, I'm trying to network because network is really bad.
Hum. Let me try to switch as well. Let me try to use MTA. Maybe it's here. Available.
Because there is yes. I was recording that when you are finding the initial basic solution, there are some steps that need to be followed, yeah? And these would include the following, right? These would include the following, and I hope you're writing somewhere. Step number one, it is called row and column reduction. Are you writing?
Yes,
Row
ma'am.
and column reduction. That is the first step. Now here, what we do actually is that under this step, you just see subtract the minimum value of each of the rows from all the entries. And also you do the same to the columns. That is how you do row and column reduction. I'll repeat, row and column reduction. This is where you deduct. You first of all identify the smallest value in the row, in each row, and then deduct that value from all the entries. Then you shall have you're going to have um, a new table. Okay. After that, you're also going to have another another table, and you also do the same to the columns, and then you should be fine. So that is the first step that you actually do, and we are good with that. So um so we get back again. So the first step is the row and column reduction. Let's do that. We want to do row and column reduction using Hungarian. So what's the minimum value in the first row, in row number one? The rows are these
9.
numbers. The smallest value, the minimum one is what?
9.
Mm-mm. You haven't looked at it completely.
6. 6.
Mm-mm. The rows are these that move like this straight.
So if we first check from the first, what is it? From the first floor, maybe we pick any low.
The first row, we are starting with the first row.
The first
Anyway,
floor
the
is
first,
not supposed to be this one is 9.
yeah, that's the first row. But what is the smallest figure in that row?
6.
Mm-mm. Anyway, I said the rows are these that move like this, so it is 7. 7 is the smallest number. And then when you come to the second row, 6 is the smallest. And from there, in the third row, 6 again is the smallest, right? But when
Mm-hmm.
you get to the fourth row, 9 is the smallest. And final again, 7 is the smallest in that end. Okay?
Yes, sir.
And so what we're going to do from here, we're going to create a new table where we're going to deduct from each row. You're going to be deducting these these numbers, right? Just deduct these numbers. I'm creating a new row, a new table. This is a new table somewhere here that we're going to create, having numbers 1, 2, 3, 4, 5, right? and on top we still have 1, 2, 3, 4, 4, 5. You're following, right? So let's have the numbers, and we shall say 9 minus 7. This will give us 2, right?
Yes.
11 minus 7.
11
What is,
minus 7 will give us 6. 11 to give us 4.
yeah, to give us 4. And then 14 minus 7 gives us
14
7.
minus 7.
Then it gives us 4. And then it gives us 0. Right?
Yes.
Mm. And when you go to this one, we said the smallest was 6. So 6 minus 6 is 0. Right?
Yes.
And 15 minus 6.
15 minus
15
6
minus
is 9.
it's 9. 13 minus 6.
13 minus
7.
6 is 7.
7 and 4. The other column is 6 again. 12 minus 6 is 6. 13 minus 6 is 7. 6 minus 6 is 0. 8 minus 6 is 2, 2. Right?
Yes.
You are following the steps. You are not forgetting. Then 11 minus 9 is 2. And 9 minus 9 is 0. 10 minus 9 is 1.
Mm.
Yeah.
12 minus 9 is 3.
Yeah. Yeah, it's 3 and 0. And then the last column, 7 minus 7 is 0. 12 minus 7 is 5. 14 minus 7 is 7. 3 and 7. Right. That's a new table for you. This is what row reduction means. Is that clear?
Yes, fine.
That is called the row reduction. Okay. Then from row
Yes.
reduction, you need to do column reduction. Yeah, column reduction. How do you do column reduction? Now we need to keep this table somewhere, this original one. We may need it again. Actually, we'll need it when finding the final answer. So let me do the row reduction. Or the row reduction has been done. Let's do the column one. Now, in the column, in the similar manner, you look at the columns and choose the smallest value in the column. So you move according to the columns. So what is the smallest value here? I think 0 is the smallest in here. In the second column, again, 0 is the smallest, yeah?
We use this
0.
as sir, sir.
Mhm.
We use the original table, we use the table that we do from the
This one,
reduction.
the new table, this new table that we have already, you do row, then you do column reduction.
On the new table.
Mm-hmm.
Oh. So for you to find a column reduction, use a column reduction method, you have to first find the low and column reduction.
First is row. The steps are you start with row, then from the row you do column.
So it's the same formula, the same method we are using for row and column. At first we used for the low, now we are using for the column.
It's the same stuff. So then you get to number 4. The smallest figure here is 2. And here in the last one is 0, right?
Yeah.
Then we can start putting the numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So you start again subtracting 2 minus 0, it will just be 2, 0 minus 0, 0, 6 minus 0, 6, 2 minus 0, 2, and 0 minus 0, 0, right? I think these, where we're just deducting 0, they will just be the same, right? 4 minus 0, 0, 9 minus 0, 9, 7 minus 0, 7, 0 minus 0, 0, 5 minus 0, 5. You're following, eh? And
Yes, sir.
3, 7 minus 0, 7, 7, 0, 1, 7. These steps are very important. I try to simplify everything and speak slowly. Yeah, but as time goes on, if you don't practice these same things, you can easily forget. Then the next one has 2. So you say 4 minus 2 is 2, 7 minus 2 is 5, 2 minus 2 is 0, 3 minus 2, 1, 1, right? And then you go, the last one has a 0, this one will be the same. Hello,
Hello.
are we still connected?
Yes, sir.
Okay. So this is about this now. So um, this is the initial basic solution, but we don't know whether this is optimal. So what we want to do now is to check optimization. So the following are the steps that follow. The next steps, when you get here, after doing the row and the column reduction, you need to do scanning. That's what you call, that is the next step. Can you write second step? It is called the row and the column scanning. Row scanning and column scanning. Just do that.
Okay.
Row and the
Mm. Column
and
scanning.
column scanning. Hmm? Now, what is in the row and the column scanning? Listen carefully. When you're doing the rows, obvious now you know what a row is. You have to ensure that you have to check if there is 1 0 in that row. If there is 1 0 in that row, then you got to put a square on it, on that 0, right? Then
Mm-hmm.
you draw a vertical line that will cancel the entire column. You have not hit. I repeat, check in that row if you only have 1 0, right? If you have 1 0, you have to put a box, a square on that 0 like this. That's what it is. Square on that 0, and then cancel the line. Draw a vertical line. What if you don't have 1 0? Maybe they are just numbers. There is no 0. If they are just numbers and there is no 0, then it's fine. You have to skip that line the way how it is. Okay, you just leave it the way how it is. You don't do anything. Again, the other question is, what if you have 2 zeros? You have more than 1 zeros. At that point, you skip that line as well, just the way how it is. You won't alter in,
So when you
right?
feel that you're not going to do anything in that table,
On that
just
column, on that row, you will not do anything on that row. We're talking about the rows space. The rows are these that move like this, going this direction. That space in this direction.
So like for example, on the first row where we have 24720, we have 10. So we put like a square here on 0. And then what are we going to do with these remaining digits? We cancel them?
When you put a square, the instructions are, when you put a square like that, you have to draw a vertical line, which will cancel the entire column like this.
So on the new table, this column won't exist. We won't have this column 5.
Don't worry about the next step. As for now, let's move step by step. The instructions are that if there is only 10 in the row, do what? Can you draw a square on it and cancel? Let's come to the second row, and we are like there is only one. There's only one is 0. So we'll draw a vertical line like this. So I done this column. Then let's come to the third row. In the third row, what happens? We have more than 10, so you leave that where it is. Let's come to the second one. Oh, the fourth row.
You also have more than 2. You have
Hello?
2 zeros. I'm saying
No,
that
this
on the
one has
fourth.
been cancelled. The other 0 has been cancelled. It's not part of it. So you just have 1. Because the other one has already been cancelled, so it's not there. You will cancel like this. Okay. Then when you come to the last one will just be left like that. It doesn't have anything, isn't it?
Yes.
Okay. Then let's come to the column. Okay. Let's start with column. Starting with the first column has already been deleted during the row reduction. The columns are these that are vertical. Even the second column has already been deducted. You're following, eh?
Yes.
Then when you go to the third column, there is 10 in the third column. So you draw a box. But now, what you do, if you are following the columns, you're doing column reduction, your line that you cancel will be horizontal. It will be like this.
Why?
Those are the instructions. You cancel like that. Those are the steps. It will be horizontal. So you see now it has
So
deleted the
always on
entire.
the third row, you cancel the horizontal.
Just
Always.
follow if that there is a 0. Not always. You just you follow. The instructions are that you follow. You are looking for where there is 10. Check if there is only 10. That's what I've said. If there is only 10, you put a box, a square on it. But here, instead of doing what you were doing under row reduction, where you are drawing the line vertical, now under column reduction, the line will be horizontal. That's what you're saying. So you put the line that is horizontal. So when you do a horizontal line, it will cancel the entire row if you look at that. Okay?
Mm-hmm.
Mm-hmm. Yeah, that's that. Any question up to here? I think Hungarian should be the easiest stuff, really. Just canceling the rows. Are we okay up to this step? Hello.
Hello.
I'm saying, are we okay up to this step? We are on the second step.
So, I'm not clear where you cancelled uh this one for row 3. Is this okay? Like the one we cancelled for column 1, 2, and 5. We are using the low scanning, and then this one for 3 is the column scanning.
Yes, I said first you do row, then you do column. And when you're doing column, you just deal with the columns that are still there. Column 1, we didn't work on it because it was already deleted according to when we were doing row reduction. It was deleted, so we kept it. We came to column 2, it was also already deleted. We left it. But when we came to column 3 and 4, they are still there. They're not deleted. So the question is that when you get to column 3, ask yourself, how many zeros do we have in this column? You get the point, eh?
Mm-hmm.
How many zeros do we have in this particular column? Okay,
So,
you get the point. If there is only one, it's the same instructions. Put a square on it, but now don't draw the line vertical. You draw it horizontal like this. That is what you do when you're doing column reduction.
so when you're doing low scanning, we cancel the vertical,
Mm-hmm.
horizontal, I mean. And then when we're doing this column scanning, we cancel vertical.
Mm-mm. Column scanning is what we have done here. We have cancelled the horizontal. Horizontal is this one which is moving from right to left. That's horizontal. But when we're doing row scanning, we're doing vertical lines, those that are upwards, that move from top to down. That's vertical.
Okay.
You got it?
Yes.
All right. Are we good at this step? We go to the third step.
Yes.
Now, when you get to the third step, you check if the number of the squares that you have drawn are equal to the number of rows. Write down that instruction. That is step. Check if the number of what? Of squares are equal to the number of what? Of the rows. Now, if the number of these squares you have drawn are equal to the number of rows, then you have reached the optimum point. Then you can just conclude from there, draw the final, how should I say, the final solution. Okay, you get the point, eh? If they are equal, the squares are equal to the rows. I didn't say the columns are equal to the rows. I said the squares. Okay.
Mm-hmm.
So when you count how many squares have we drawn? There are how many? One,
So,
two, three, 4. So squares are 4 equal to how many rows are there? The 5 rows, right?
yes.
So they are not equal. If they were equal, you could have just left it there. Okay. You have heard.
Yes.
So now, since it's not the equal, what do you do? That's the next question. What do you do? If they are not equal, the instructions are, if not equal, then you go to the next step. In the next step, listen, the next step, you have to write down these steps so that you're not forgetting. The next step is that you identify the minimum value of undeleted cells. Write down. That's the next step. You can write down. A,
What we do it.
identify the minimum value of undeleted cells. Those cells that are not deleted. Identify the minimum value. I've written that.
Mm.
Number 2, B, you add the minimum value to all intersection of the matrix. I'll show you using a practical problem how you add. But as for now, can you write that you add uh, the minimum value?
Add
You
the
add,
minimum value.
to all intersection of the matrix. Add the minimum value to all intersection of the matrix. Add minimum value to all intersection of the matrix.
Okay.
Add the minimum value to all intersection of the matrix. And when we get to B, to C, can you subtract the minimum value, from all cell values, okay, of the undeleted cells of that head, subtracting the minimum value, right?
Mm-hmm.
From all cell values that come from undeleted cells. All cell values that come from undeleted cells, those cells that are not deleted, you will subtract that minimum value which I've identified. And the number D, all other entries shall remain the same. Okay? All other entries to remain the same. Okay? All other entries to remain the same. Have you written that? We go on
Yes.
now. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5, right?
Mm-hmm.
And when you do this is what you're going to do. What did we say? We said the first thing, you identify the minimum value from undeleted cells. So from these cells that are not cancelled, that don't have any line with, what number is the smallest?
Mm, 2.
Mm-mm.
So it's
Okay,
1.
there is 1. Yeah, there is
Mm-hmm.
1. So first of all, 1 is the minimum value. What do you do next? What's the next step?
Mm, you add the minimum value to all intersect of the matrix.
Intersection. Where the
Yeah.
lines are intersecting. For example, in row 3, that's where they're intersecting. So you're adding 1, 6 plus 1, 7, right? The next one is 7, isn't it?
Mm-hmm.
7 plus 1, 8.
8.
Uh, only on the intersection. Where it is also intersecting at 5. Mm, 2 plus 1, 3. You're following?
Which 5 have you got it?
That's what you mean when you say row 5, like the last here on 2. Here is an intersection. Also this one and this one. They're the intersections. Like where the line you drew for the column and for the what's this row is cutting.
Mm, okay.
All right. What's the next step?
You subtract the minimum value from all cells, from all undeleted cells.
Mm-hmm. So undeleted cells include 7 here, right? You have 7. You have this 7. 7 minus
Mm-hmm.
1,
7 minus 1 is
6, right?
2.
And the 2 minus 1, is 1. Then 7 minus 1, 6. 5 minus 1, 4. Right? Then deleted cells. And these other ones we got in row 4. 1 minus 1, 0. 1 minus 1, 0.
Yeah.
7 minus 1, 6. And 1 minus 1, 0. You're following, eh?
Yes.
I'm trying to teach slowly as if I don't know. Yeah. So that's that. What's the next step?
It's saying all other entries shall remain the same.
They remain the same. So all these other ones will just remain the same. So it means here you shall have 2, 0, 2, and 0, right? In the column for 8, this one we have 4, 9, right? After 9, this one will be 0, and the other one will be 5, isn't it? And then we'll
Mm-hmm.
go to these ones, the zeros, the zeros. Then this will be 0, 4, 0, and 7. That's that. You only do this if the number of squares that you did at first is not equal to the what? To the rows. Okay. All right. Then from here, the next step, which is step number 4. Step number 4 says go back to step 1. What is under step 1? There is the row and the column reduction. There's again row and column reduction. Hello?
Hello?
You're following, right?
Yes,
You can do row and column reduction. But after doing all this, could even just do the scanning row and column zeros and all those stuffs. That's the actually this is where you do the scanning, not the reduction. Sorry, the scanning. So we start with the row. When you're doing row scanning, you just check if there is 1, 0, and cancel the R, isn't it?
yes.
So what is in the first row, there is just 1, and what do? You cancel the whole lot of this, isn't it? Next row,
Mm-hmm. The next one is 1.
only 1, 0, you cancel. Next,
There's no
there
0.
are there are 2
Oh,
zeros you
yeah.
skip.
There are 2 zeros.
Number 4, again, there are 3
More than
zeros you
4.
skip. Number 5,
1.
there is only 1, 0, and you cancel this. Let's go to the what? The columns, eh?
Mm-hmm.
Yeah, columns now. We know that the first column has already been deleted. The second column has 1, 0, right?
Mm-hmm.
We cancel horizontally like this, isn't it? That's what we thought, right?
Yes.
And then
Mm-hmm.
number 3, how many
There's
zeros?
also 1. 1.
Eh?
It
Just
has
as
1.
1. Then you also cancel like that. And what did we say when we get here? Again, you go
It
back
says
to
the number of
check.
squares and the number of rows are same.
Yes, how many number of squares now? 1, 2, 3, 4, 5, right?
Mm-hmm.
Now 5 is equal to 5, the number of rows, which simply means that this is the optimal solution, okay? This is the
Mm-hmm.
optimal solution. So the next step that you do now, to present your final answer, all right? The final answer, you present it like this. These are jobs. There is job, then there are operators here, and then there is time, right? So the jobs that are there is 1, job 2, job 3, job 4, job 5, right? Now,
Mm-hmm.
let's go on to the operators. In job 1, it is operator number what? Operator number 5, right? Where there is a square. Like you follow the rows, the jobs are these, the rows. Where there is a box is on 5, right? It's operator number 5, isn't it?
Mm-hmm.
Job 2, operator number 1, right? Job 3, operator number 3, yeah? Job 4, operator number 2, and job 5, operator number 4. You're following, eh?
Yes.
You just take where these boxes are. Then now, if you want to get the actual time, listen, the actual time, remember these positions where they are, where they're my boxes. When you go to the original table, that first question, the problem there, you find the numbers here, like in position of these boxes. They are numbers. Remember? They are numbers. Are you following? I mean, the very
Yes.
original problem, like the question itself, the table that we started with, it had a number here where there's the number which sits on that position, on position number 5. And actually that number was 7, right? And then on position 1, like in the second row, there was, because I remember you were writing. I don't know if you didn't just write the time. There was 6, right? And again,
Where?
in the third one, there was 6. Like on these positions where there are these two squares, when you go back to the original table that you had started with, it had the numbers.
So on one it was 7, and then the second one it was 6, and then the other one was a 0
Where?
on
No. Like
row.
the original question, like the very question we started with, the first table I drew, it was just like this, but where there are these boxes, there are numbers, those original numbers. They're the ones that you're talking
So
about.
on like a square number 1 there was 7, then like a
Mm-hmm.
square number 2 there was 6,
Mm-hmm.
the square number 3 there was 6 also,
Mm-hmm. What about 4?
4 there was 9.
There was 9.
Yes, on
Mm-hmm.
5 it was 10.
It was 10. Exactly. Then you just add these. These are hours. It's time, in terms of hours. Add everything. Total processing time. This is going to be a total processing time, right? How many hours? Total processing
Mm.
time. 38 hours. That's the total processing time that was required, the optimal one. We're good.
Yes, samani vambili
No,
vambili
is
tu.
that no? It's just because I was teaching and I was slow.